Hello, so good day everyone. So for this week, we will have our week 2 discussion wherein we're going to discuss for EE6301 feedback and control system, the topic about Laplace transform and system modeling and the transfer function. So without further ado, we'll discuss week 2. So the introduction for this Laplace transform is to pinpoint the importance of the topic. So the importance of the topic is to develop mathematical models from schematics of physical system. So wherein we will discuss two methods. First is the transfer function and second is the state equations. So the transfer function will focus mainly on the frequency domain while the state equation will go to the time domain. So the first step in developing a mathematical model is to apply the physical laws of science and engineering. So it would be best to recall the things that you have learned in physics, electrical circuits, and electronic circuits in order for us to have a better grasp on the topic. In modeling electrical networks, Ohm's law and Kirchhoff's law are the basic laws of electrical networks, which will be applied. So as I've said earlier, it will be important for us to have a better understanding of these electrical networks. So we need to remind ourselves what are the laws important for us to use. So the Ohm's law, wherein the voltage, current, and resistance relationship must be also applied, and the Kirchhoff's voltage law and the Kirchhoff's current law. So those two, uh, KCL and KVL, will be also used in this. So mesh law and superposition theorem can also be applied in this topic. In mechanical system, Newton's laws are the fundamental guiding principles wherein we need to have the summing forces and torque, and from this equation, we can obtain the relationship between the system's output and input. So a mathematical representation such as what is shown below is preferred. So we have discussed this in the last video for the week 1, wherein the input, output, and the system are distinct and separate parts. So we have here the input that will undergo to the system and you will receive an output. So yung RT natin would be the reference input and the CT is the controlled variable. That is why it is represented by R of t, or the R with the function of t, and C of t, wherein it is embodied by reference input and controlled variable. So we have here the Laplace transform review. So it would be just a review for you because this had been a topic in advanced engineering mathematics and differential equations wherein Laplace transform had been introduced. So a system represented by differential equation is difficult to model as a block diagram. Thus, we use Laplace transform in which we can represent input, output, and system as separate entities. Further, their interrelationship can be simply algebraic. So the approach in block diagrams can be very difficult and complex, but with the use of Laplace transform, we can differentiate them and make it more easier to understand. So, define Laplace transform and how can it be simplified with the representation of physical systems. The Laplace transform is defined as the Laplace transform of function t is equal to f of s, and it can be also be defined as the integral of 0 going to infinity with the function of t, or f of t, exponential raised to negative st dt. So that would be the Laplace transform equation, wherein our s is the represented as a complex variable, thus knowing f of t and that the integral exists, we can find the function f of s that is called the Laplace transform f of t. So Upon giving us an equation, we can further define what is the co-equivalent of this equation. So we have here the Laplace transform table, wherein there are several items that were once introduced to you in advanced engineering mathematics. And the function t um, equation and its co-equivalent to the f of s. So we have here different equations such as yung u of t, tu of t, tnu of t, and their co-equivalent. So once that you have that kind of equation, then it is equivalent to the or it has the relationship between them. So yung u of t natin is equal to 1 over s and so on and so forth. So we have here the Laplace transform theorem wherein different theorem has their own names. So si number one is the definition of Laplace transform, as I've said earlier, yung integral of 0 going to infinity ft negative st dt. So yung mga sumusunod, may kanya-kanya din silang theorem. So yung second one and third one is yung linearity theorem natin, wherein the constant is multiplied to f of s, or pwedeng yung function 1 or function sub 1 of s plus function of 2 sub s. So those are both linearity theorem. So when it comes to frequency shift theorem naman, that would be equal to f multiplied to ds plus a. And pag time shift theorem naman, it is equal to the exponential raised to st, negative st, f of s, while the scaling theorem is 1 over a, f multiplied to s over a. And lastly, the differentiation theorem is equal to s f of s minus f multiplied to 0 negative. So this is the different theorems that were taught to you in advanced engineering mathematics, and in this feedback and control systems we have different kinds of application for that. So once you have already encountered those theorem, so it would be good for you to understand na there are terminologies that are applicable for that theorem. So 8, 9, 10, 11, 12. So those are also differentiation, integration, and final value theorem. So I won't be getting into terms with that because it has been taught to you. So the differentiation theorem, so as you can see there, that is the equation for that. Integration, f of s over s, while the final value will use or optimize the use of limits going to 0 and going to infinity. So si final mo will be using your initial as 0, and your initial value will use infinity as the limit for s. So the transfer function. So the transfer function of a linear time invariant system, or yung LTI na tinatawag natin, can be defined as the ratio of Laplace transform of an output and Laplace transform of input by assuming all the initial conditions are 0. Please do take note that the initial conditions should be always 0. Right, so this involves that the system, or the system given to you, has no disturbances, noises, and other factors that could affect your output. So we will assume that the conditions in that environment are there are no noises, there is no existing disturbances. So that is an ideal condition lang naman. So when we say ideal, it is different from practical. So ideal condition natin is yun yung gusto natin mangyari, while the practical is what is really happening. Right? So hindi naman natin pwedeng i-assume na the system is completely perfect, no? So wala namang perfect system. So therefore, the concept is to assume that the conditions are 0 or noiseless, walang noise, walang disturbance. So the LTI system natin is the complete ratio of the output to the input. So that is what you will stick to. So when you hear a LTI system, you should make sure that your output is the ratio of the output to the input. So the transfer function or TF natin is equal to C of S over R of S, and it will be called the G of S. So the formula for that would be, para hindi kayo malito, is G of S is equal to C of S over R of S, wherein yung controlled natin is the numerator and yung ating reference input would be the denominator. And as I've said earlier, so the output natin has the relationship or the ratio to the input. So si output ang C of S over the input, which is R of S. So we have here the remark. So remark natin dito is the transfer function is always computed with all initial conditions equal to 0. So na-discuss ko na siya earlier that it must always be in initial condition natin ay 0. Then the transfer function is the Laplace transform of the impulse response function. Standard forms. So transfer function of a differential equation. So we have here an example. So this is just a review of your DE class. So find the transfer function represented by dc of t over dt, or your rate of change ni c over with respect to time, plus 2c of t is equal to r of t. So ang gagawin mo lang dyan is to take the Laplace transform of both sides. Yun lang yung gagawin mo. So after taking the Laplace transform of both sides, of course, you'll assume that the initial conditions would be 0, therefore giving us a transfer function g of s equal to c of s over r of s. Please do make sure that when you are in the step of sc of s plus 2c of s equal r of s, gagawin mo na lang dyan is to transpose. So kailangan na magiging final equation mo dyan would be c of s is equal to r of s. So ang gagawin mo kay c of s over r of s is gagawin mo siyang si C of S, ilalabas mo. So si C of S mo, then since nailabas mo na siya, divide both sides mo yung kabilang part. So mangyari, magkakaroon ka ng S plus 2, di ba? So since may S plus 2 ka na lang here, so let me show you. Alright, so medyo may conflict ako sa ballpen. Pero please do make sure that the C of S is will be divided. I-divide mo muna yung nasa kaliwang part by C of S para mailabas natin siya. Therefore, you will have C of S multiplied to the quantity S plus 2. Then, close parenthesis is equal to R of S. Since meron ka, nahiwalay mo na yung C of S and yung R of S, ang gagawin mo na is to have the final output. So, ang gagawin mo, si R of S, ililipat mo sa kabilang side. So, therefore, magkakaroon ka ng value na 1 over S plus 2. So here we have the electrical circuit. So medyo mukha siyang mahirap, pero we'll take that into consideration, no? So we have three different components. We have the basic, so meron tayong RLC. So yun yung ating three passive linear components. Please do take note that the three passive components would be the RLC. So si resistor, inductor, and capacitor. So nandyan yung symbol for resistor, capacitor, and inductor, and I think you have already passed the fundamentals of electronic circuits, or the electronics 1 and electronics 2. So, or circuits 1, circuits 2. So these are all familiar to you. So we have here three categories. We have the voltage current, current voltage, and voltage charge. So these are all the equivalent factors for that. When we say voltage current here, it is the relationship of your voltage to current, and the current to voltage naman is your current relationship to voltage, and voltage is the relationship to your charge. So when you are finding the when you are let's say summing a circuit wherein it is important to sum up the voltages using their current, so ang gagamitin mo dito is yung voltage current niya. Likewise is pag ang ginagamit mo naman is yung KCL natin, wherein yung ating circuit is using the summation of your current. So ang gagamitin mo naman dito is yung voltage. So ganun din sa charge, no? So it would be best to have a recalling of your Kirchhoff's voltage laws, having voltages around loops and meshes. So we call this method loop or mesh analysis, wherein si mesh analysis naman had been a topic for electrical circuits or circuits 1, or I think electronics 1. So these are kumbaga review na lang silang lahat. So we have here mechanical system that optimizes the use of Newton's law. So ito ay parang review lang and summation of all forces. So si Fe natin here is equal to K of Kx. Si initial force natin or si Fi is Ma, wherein it is also equal to the mass multiplied to the derivative of V over derivative of time. And also it is also equal to md squared x over dt squared. Then fd, which is equal to cv. So si cv natin, it can be also be derived as c dx over dt, wherein our condition will be finalized as the summation of all forces. So f minus fe minus fd minus fi is equal to 0. And these Fe, Ft, and Fi can be also transformed to equations such as Kx, Cdx over dt, and Md squared x over dt squared. So let's try a problem here. Use the result of example number 1 to find the response C of t to an input R of t is equal to U of t, a unit step, assuming zero initial condition. So you have here the word, the phrase, assuming zero initial condition. So it is safe to assume that you can proceed to the next step. So to solve the problem, we use the transfer function obtained in example number 1, wherein our answer is 1 over s plus 2. So since r of t is equal to u of t and r of s is equal to 1 over s, and we have here that the initial conditions are 0, we can proceed to the next step. So our next step is C of S is equal to R of S multiplied to the G of S is equal to 1 over S multiplied to S plus 2. Again, multiply lang natin yung value ni R of S doon kay G of S. So, 1 over S multiplied to 1 over S plus 2. Therefore, kaya ka merong S times S plus 2. So, using partial fractions, ang gagawin natin, so C of S is equal to 1 half over S. Then meron din tayong 1 half over S plus 2. So since you have here the value of your C of S, ang gagawin natin is to take the inverse Laplace transform of each term. So magkakaroon tayo ng C of t is equal to 1 half minus 1 half e raised to negative 2t. So that would be the answer for that example. So we have here the electrical network transfer function. So again is just the review yung sinabi ko kanina. First, take the Laplace transform of the equations in the voltage current column assuming zero initial conditions. So as I've said earlier, when it is a relationship between your voltage and your current, these are the following things that you have to have in your mind. So for the capacitor, we have V of S is equal to 1 over C of S multiplied to the function of S I. So yung 1 of CS multiplied to IS, yun yung magiging equation natin when it comes to the capacitor. So for the resistor, so we have V of S is equal to Ri of S. So that is just equivalent. Co-equivalent lang yan using Ohm's law. So, ganun din, pag inductor, ang formula ng voltage natin of S is Ls multiplied to Is. So, for the transfer function relating to the capacitor voltage Vc of S to the input voltage V of S in the below figure. So, hanapin daw natin yung transfer function. So, how would we do that? So, first is I'll give you enough time to look in the circuit, then we will try to solve that. So the answer for this circuit would be to analyze first. So we have here V of t on the other side or the terminal natin going to the potential difference across your capacitor. So in order for us to receive that, so ang hinahanap daw is yung reference input natin would be V of t, and yung atin namang controlled output would be the voltage across your capacitor. Yun kasi ang hinahanap natin according to the problem. So si capacitor voltage natin would be your output and yung terminal voltage natin would be your input. So ang mangyayari dito is we need to summate or to get all the equivalent voltages across your inductor, your resistor, and of course your capacitor. So in order to do that, kailangan mo i-sum up yung voltages natin. So ang sabi dito is there is a current I of t that is flowing across your circuit. So therefore, this is clearly a voltage current relationship. So since this is a voltage current relationship, going back to the uh, given sa atin, this is a voltage current, we will use these three to solve the problem. So ano ba yung unang dinaanan niya? So unang niyang dinaanan is L. So that is L di of t over dt. So I hope na nakakasabay kayo kasi wala akong ball pen to write that down. But those are the factors, no? So L di of t over dt plus R I of t. So ito yon. So isa-sum up lang natin si inductor kay resistor kay capacitor. So L di of t over dt plus R I of t plus 1 over c integral of 0 going to 1. Um, pero in this case, so ang gagawin natin is to use t for time. So I tau d tau. So yun yung gagamitin natin and it would be equated to V of t. So that would be your equation for that. So sir, paano po kaya siya nagkaroon ng final answer na nandun sa kanan? So you need to change, of course, no? So you need to derive that equation. So first is to change the current to charge using I of t, which is equal to dq of t over dt. So in order to do that is to isa-isahin mo yon, no? So wag kayong mabother kung masyadong mahirap yung gagawin kasi this is just a transformation from one form to another. So ang gagawin mo is unahin muna natin si LDI of t. So paano natin gagawin yon? So ang gagawin natin is convert mo yung IT into dq t over dt. So magkakaroon ka ng L multiplied to the quantity d squared q of t over dt squared. Now, next naman natin is yung Ri of t. So, yung Ri of t natin, so ang gagawin natin is, ko-convert lang natin si I of t into dq of t over dt. So, that will, we will have R multiplied to the quantity dq of t over dt. Then, lastly, is to convert I tau natin. Ang nangyayari doon is to have 1 over c multiplied to the quantity q of t. Now, meron na tayong q of t and still it will be equated to V of t. So, next is to convert the voltage to charge for the capacitor. Since we all know that the capacitor is a component having charges, di ba? So, nagcha-charge ang ating capacitor. So in order for us to do that is to convert all Q of t into CVC of t. So that is CVC of t. So simplify na natin yung nakuha nating equation. So may nakuha na tayong equation. So si LC, multiply natin into the quantity d squared VC of t over dt squared plus RC multiplied to the quantity dVc of t over dt plus Vc of t is equal to Vt. And it will all be equal sa LCS squared plus RCS plus 1. Yun yung quantity natin. Then Vc of S is equal to V of S. So ngayon, na-extract na natin si Vc of S at si Vs. Ang gagawin natin is kunin yung relationship nila together. So since meron na tayong equation, so ang gagawin natin is to transpose lang natin si Vc of S sa kabilang side para makuha na natin yung equation na VC of S over Vs is equal to 1 over LC all over S squared plus R over L S plus 1 over LC. Right, so that is the solution for this problem. So that would be all for this week. So that is the week 2 of our class in feedback and control system. So thank you very much.